This week for ETH Denver, we built the Web Token Forwarding, or WTF protocol. This forwards your JSON Web Tokens to the blockchain and allows you to link your Ethereum address or address on any L2 or EVM compatible chain, such as Harmony or Arbitrum or Polygon or Avalanche. Allows you to link that account to your Web2 credentials. So this problem has never been tackled to our knowledge from this angle. Services such as Taurus do a great job of generating new keys for people based on their Web2 logins, but this is the first known solution to us that allows you to authenticate your Web2 credentials via JWTs on the blockchain. So one thing you can do for this is recover your password. For example, if you integrate with the LIP protocol, you can store your private key to Bitcoin or Ethereum, etc. on the LIP protocol and make an access control condition that anybody who can authenticate with a bunch of social credentials can recover the password. And of course, as a trade-off, the safest thing is always to remember it in your own brain, never write it down. But this enables that option. And another interesting option it enables is, for example, we can do fun stuff like vampire attack Gmail. Anybody with a Gmail account can log in to the blockchain, so to speak, link their public key with the Gmail account, and then you can onboard Gmail users to the blockchain and have a blockchain-based email client for fun. And the most straightforward solution, though, is, of course, identity. So for DAOs, when you want to authenticate users, this is very helpful in DAO tooling, linking a public key that has already contributed a lot to DAO, proving that it's actually from social credentials. We designed this for scientists to prove that they wrote the papers that they're submitting to blockchain. So let's see how it works on the scenes. So first, you request an access token, an ID token, because you don't want to authorize, you just want to authenticate. And you send it to a smart contract. This is a naive way of doing it, sending in plain text. Then the smart contract, we built a smart contract to verify the signature on that token, compared to using the public key of, for example, Google. But it can be front-run because you're submitting the JWT in plain text. So we built a commit reveal mechanism so that it can't be front-run, right? Because then anybody can claim, oh, I actually own this JWT. So first, in the more secure solution, after requesting the ID token, you add it, or rather XOR it with your public key, and then you hash that, submit that on chain. So then there's no way of recovering your original JWT from that hash. But then in a later transaction, you submit the raw JWT, and then you refer to this previous transaction saying, hey, hash this raw JWT with my public key, and then you can see I have proven before that I knew this. So you can't be front-run that way because it happens over multiple blocks. So the end result is that you get your keys linked to your social credentials. Let's see it in action. So the Google and Facebook logins are still a work in progress. They require some authentication on Facebook and Google's part of our actual app, which takes some time. Right now, the Orchid authentication, though, does work, so we'll have to paste JWTs in the meantime. And we'll connect our wallet. And paste our JWT. And it's going to prompt you by telling you, okay, good, your JWT is expired. Nobody can use this to gain unauthorized access. and it lets you verify that you're okay putting all this data on chain. This looks safe. We click verify identity. It's going to pop up MetaMask, and it's going to take some time because we need to wait long enough for the transaction confirmations to make sure you can't be front run. And now we just have to confirm the second transaction. There you go, successfully verified.